Doop. All right, here we go. Remember where we were last time? We wrote this thing where we were building up some sort of HTML. So I guess we're starting here on nested APIs. Let's see how you can define APIs in a modular way while avoiding repetition. Create a new file. Call nested. Oh, well. We need some stuff here. Probably all of this. Gonna need probably just this. I don't really know what yet. We'll see what we need here in a second, but we'll start here. Luckily, the compiler will tell us what we need. So apparently this is like a an example we're starting with. Oh, I'm gonna need to get user as well. Hello, someone. How are you today? We took the day off today. Well, not to specifically stream, but that's what we're doing anyway. I'm gonna need the user data type clearly. Oh, content. Okay. We need to put that there. Need to put this here. Put this here, I guess. Unfortunately, we have to work in this sort of side-by-side mode so we can read the tutorial and code at the same time. So unfortunately, this screen's a little smaller than I'd like, but hopefully this screen's at least readable. Okay, so what is this? This is we're just gonna capture a user ID. Or, sorry, we're either gonna get a user ID or we're gonna delete a user ID. Their user data somewhere. Give me a second. Here's our user. Day. Here it is. Probably don't need these anymore. We're just gonna make this thing compile. Oh, day comes from, where does day come from? UTC. We're gonna need this. Oh, I'm missing an S. And then we need this day, which I think comes from, probably from here. Okay. This is just a typo. And there we go. We're compiled. All right. So we're talking about nested APIs, by the way. So this is basically what we're doing. So we're starting with this API, and then I guess we're gonna clean stuff up. So we can apparently clean this up by doing this. Capture user ID int if you guys have any questions, feel free to shoot them out. If you don't understand something, that's fine. We can figure it out together. I don't know if this is considered the way you should format this. Oh, but I call this like. All right, so this piece is basically nested inside of this capture. So you're going to capture the user ID and then either do your get to return a user or a delete. I don't know if this formatting is correct, but that's what we're going to go with. I mean, over here it's a little different, but I'm trying to conserve space as best as I can. All right, so however, you have to be aware that this has an effect on the corresponding type of the corresponding server. Okay, so this we just call this API, and then we call this one API 4. So okay, sweet. So just change this up a little bit, but that's okay. We just need to remember that side there. But you know, this does decrease duplication because we'd have to write this each time. So let's see how that's useful. In the first case, each handler receives the user ID argument. In the latter, the whole server takes the user ID and has handlers that are just computations in handler with no arguments. Okay, so we'll just write them. Hey, kitty, no. Hello, other user. How's it going? We're working on some servant today, but I'm gonna have to do some kitty wrangling because kitty doesn't like being by himself. I mean, he's not by himself because I'm here, obviously, but he can be kind of a butthead sometimes. Why are we erroring here? He's playing with a spray bottle right now, so if you can hear him, I'm sorry, I suppose, but that's what he does. Okay, so I think the point of this is just showing the difference between the two things. So we really don't need to write error here, we can just write undefined. Kitty, could you stop, please? Could you stop? Hello, other user. How's your day? I think there's 3 people watching. It's hard to tell because the MooBot screen's pretty slow, but hope everyone's having a good day so far. I have the day off, so I'm having a good day. Yeah, okay, so so this time you actually have to feed the user ID to get user. Otherwise, the thing doesn't work. Oop. So that's the difference between these two. Whoops. So we can just wait, why is this here? There we go. So this time interesting. I'm trying to remember what these functions are for. So let's go look at another example because I'm just a little confused. Turn wraps these things up into a handler. We just have these things are just a handler for user and a handler for no content. Okay. I don't know why that they put errors in here, but okay. Note that there's nothing special about capture that lets you factor it out. This can be done with any combinator. Here are a few examples of APIs with a combinator factor out, for which we can write a... What is that noise? We can write a perfectly valid server. Okay, so here's an example where we just factor out the user's path fragment, right? So just so everyone's clear, because I don't know how familiar you guys are with this. So let's just put this in here. Okay, so we have all of these are going to be on users, and then we have a get. So I guess you just have get users, and this is a get specific user. So it's like get users user ID. Okay, so that's the difference here. So all you're doing here is you're factoring out the fact that you have this path. Okay, I think anyway. View a particular user, yeah. So this one, these should go over too. Formatting when I'm pasting in is a little weird. What is this noise? It's a very weird noise. I'm not sure if it's coming from my computer or not. Okay, what's request body? So this is a post well, there's apparently a get and a post, but so this is a get on root, but with a request body. I don't know how to write that here, but that's getting a user, I guess, or a post on root. Anyway, I think you see the point here. But anyway, you can write these things to factor this out. I think this is right. You just have a request body in that case. This approach lets you define APIs modularly. I can't say that word apparently. Modularly, and assemble them all into one big API type, only at the end. Okay. So here's a. Let's look at this one carefully. Oops. Okay, so let's tab this out. And this is part of, this, I guess. This down here so you guys can see it. And we'll do the same thing here. Okay. I know what it is. Okay, I figured it out. It's my water bottle. So I put cold water in the water bottle and then shut the cap, and it's like off gassing, I guess, because it's warming up. Okay. Here we go. This one's kind of confusing to me. So this is like, you're doing a get on root or a post on root or a get on user ID or a put on user ID or a delete on. I think that's right. So you can write all kinds of pretty interesting types to make all this work. Which, by the way, on my night streams, we're going to talk about how this all works at some point. Either Sunday or next Tuesday, I suppose. All right. I wish this said undefined and not error. Okay, so this one is kind of a similar thing. You're gonna have a get on root for all the products, a post on root for all the products, and then for a product ID, you can either get, update, or delete. So there's a very similar shape to this API as the user's API that we just looked at. Okay, neat. Oh, that's cool. So then after you wrote users and products, you could simply just put them underneath another location and combine them together. So you can write all your APIs separate and then have one server. Well, I guess you need multiple servers. Yeah. So like these can go in separate files, but at the end of the day, your APIs can all go on different path segments. So that seems pretty useful. Yeah, and then of course, because those are basically the same thing, you can abstract that away. Just stick what you need in there. So that's pretty easy. When your API contains the empty API combinator, you'll want to use empty server in the corresponding slot for your server, which will simply fail with 404 whenever a request reaches it. Okay. Now, using another monad for your handlers. Remember how server turns combinators for HTTP methods into handler? Well, actually, there's more to that. Server is actually a simple type synonym. Server T is the actual type family that computes the required types for the handlers. That's part of the Has_server class. It's like server, except that it takes another parameter, which is the monad you want your handlers to run in, or or more generally, the return type of your handlers. This third parameter is used for specifying the return type of the handler for an endpoint. For example, when computing server T get JSON person some monad, the result would be some monad person. Okay. So the first and main question one might have is then is how do we write handlers that run in another monad? Nope. Here he comes. Hey buddy. Say hi to Andre. Hello. You need to be held for a second? I'll hold you for a second. You come in. Not gonna be. Okay. How can we bring back the value from a given monad into something servant can understand? Okay. I've seen this before. We have natural transformations, I mean. If we have a function that gets us from MA to NA for any A, what do we have? Function that gets us from MA to NA for any A, what do we have? Apparently this. Note that servant doesn't declare the, I don't know what to call this, squiggly arrow type alias, as the unfolded variant isn't much longer to write. We'll see shortly. If you want to write handlers using another monad type than handler, say the reader string monad, the first thing you need to have, oh my gosh, why can't I read some days? The first thing you have to prepare is a function. Reader to handler. We obviously have to run the reader computation by supplying it with a string, like hi. We get an A out from that, and we can just return it into our handler. Okay. Obviously, we need this string. We can write some simple web service with the handlers running in reader string. Okay, so we unfortunately can't use the reader server T as an argument of serve because serve wants a server reader API. In other words, with handlers running in handler, but there's a simple solution to this. Welcome hoist server. That's right, we have just written reader to handler, which is exactly what we would need to apply to all handlers to make the handlers have the right type for serve. Being cumbersome to do by hand, we provide a function hoist server, which takes a natural transformation between two parameterized types m and n and a server t sum API m, and returns a server t sum API n. Okay. So I suppose we should probably write this into a file. Reader we'll call it that, I guess. Copy all this stuff. And we're gonna need servant, obviously. Reader comes from, I think it comes from control monad reader. Yep. Okay, and then let me clean this up a little bit so it's a little more readable on your screen anyway. Well, hopefully on your screen. Okay. Oh, I do need that reader to handler, but I feel like that reader to handler is not the right function. What are you doing, you weird cat? Did you get out of there? This seems like the wrong function, but that's okay. We can fix it, I suppose. Shouldn't this take... Oop. Server. I could spell. Reader API, reader to handler, reader server T. It's a mouthful. Okay. And apparently this is all we need to make this work. Not 100% sure why you'd want this. Maybe it's just because you already have an API that uses reader and you want to turn it into a web API or something. So why So this takes a reader string A. A reader string A, a string. Kitty! Oh my goodness. Hang on, I gotta get this cat out of here. Come here. Where you doofus? Get out of here. Okay. He gets really, really antsy, like, when I'm here and not paying attention to him. He's more like a dog than a cat, which is really obnoxious. I mean, obviously it's nice because he's not one of those cats that just stay by himself all the time, but you know, when you're trying to do something, it's very hard to deal with him. I must be very sad when we're gone, huh? Back over there. Probably now absolutely covered in cat hair as well. Okay, anyway. So what's this string about? Don't bite my feet now. Okay, anyway, if we run this thing, well, we'll see what we get. Here, let me make this bigger. Hey, stop! Literally biting my legs right now. Oh, I didn't finish the rest of this code. Do import reader API. Here. Could you stop, kitty? Seriously. Being very bad right now. Whoops. Run. Okay. So stack run. Hopefully we don't need to install anything. No, we don't. We just need to compile some stuff and then run the thing. So it should be running now. And we can okay. This B one is a little more confusing to me. We'll have to think about this a little bit in a second. Okay, so why is that true? That's the question. So this. So B takes a double in the request body and returns a bool. This is a very weird function. Okay, so I see what's going on now. So what we do is we take a double and then literally do nothing with it. We're just saying this thing returns a reader string bool where we wrap up an equals equals high into a reader t that returns a bool. Takes a string, returns a bool, right? So that's what this is doing. Then we run our reader by basically seeing if this thing is equal to high and go from there, I guess. So could we do this in a different way and actually use this double for something? Let's see. So it's not going to take a string anymore. It's going to take a double. And up here, we're going to take a double. And we're going to say... this is going to be reader. Okay, so now we can check if we get 42 that it returns true, and it should return something else if it's not, I guess. Let's see if that's actually correct. You know what I should probably do when I have to work like this is put a new line character after this so it's a little easier to read. Okay, so if we give that 42, we should get true, and if we give it, you know, some other number, we get false. Okay, cool. That was kind of a weird example because of the way it was written before. Just like it could only ever return true, so I wanted to write something that you could at least get false out of it. I guess that's interesting. I'm not 100% sure where people use this. It again, it's probably cases where you basically have already written your API in terms of reader. An arrow is a reader too. In previous versions of servants, we had an enter to do what Hoist server does now. Enter had an ambitious an ambitious design goal, but was problematic in practice. By the way, I do remember we found an error with this. We should probably just go through and do some text edit on this and just, you know, suggest that they fix those things. One problematic situation was when the source monad was arrow R, yet it's handy in practice because arrow R is isomorphic to reader R. We can rewrite the previous example without reader. Okay. Fortunately, we can't make string the first argument. Okay. Sure. I don't know when this is useful, I'll be honest. But it's interesting nonetheless. Okay, so now we're going to talk about streaming endpoints, which I think are going to be fascinating. We can create endpoints that don't just give back a single result, but give back a stream of results served one at a time. Stream endpoints only provide a single content type and also specify what framing strategy is used to delineate the results. To serve these results, we need to give back a stream producer. Adapters can be written to pipes, conduit, and the like. That's another thing that we don't know a lot about is these things. I don't even know what they're called. I guess I can just the pipes, Haskell. I think they're just streaming compositional pipelines. Stream processing library. Sure. Okay. Source IO or written directly as source IO. Source IO builds upon servant's own source T stream type. It's simpler than pipes or conduit. The API of a streaming endpoint needs to explicitly specify which sort of generator it produces. Note that the generator itself is returned by a handler action, so that additional IO may be done in the creation of one. Okay, so let's create this, I guess. Stream. and then we can just take the code here. We probably need this. We're going to need I don't know what else yet. Stream API. Hello, new chatters. How's it going? How was your day? Stream get. New line framing. JSON. Source I. Oh, here. Let me. Source IO user. Okay, so I need the user data type, which is not here, but in here. No, it's just in there. Here's my user data type. Here it is. And I think this is day, which comes from data, time, calendar. Get rid of this. Okay. And then we need these users, which are, I think, are also in here. Slash. Is there? Yeah, there is. So we'll take these two users. There's definitely some like useful stuff in here that I need to use more often. I mean, like having search is pretty easy to deal with. Okay, so now we have this stream API type. Then we need the proxy for the actual API. So proxy API stream API equals proxy. We need our users source IO. Oh, that comes from servant. Okay, I thought we were gonna need that from somewhere else. Source serve stream. Oops. We need this. Deriving show. We need GHC generics. We need instance to JSON user. Okay, cool. Oh, that probably comes from async. Probably just this one. And then we still don't have this source thing. Where does source come from? Maybe we are going to learn. Source IO. I'm not sure where this comes from, so we're gonna Google it. Source. And we want to look for it in servant. Types source T. Import servant types source T. There we go. This. All right, so what if we hit this API, I guess? What does it do? Understand. I've not done anything with streaming APIs. I mean, I guess I haven't done a lot with APIs in general, so I don't really have an idea of what this is going to do. Stream API app. And then I guess we'll see what happens. So how's everyone in chat doing today? Anyone at work? Hanging out at your home? What's going on? Chat has been very quiet today, which is pretty surprising. Maybe that's not that surprising, but it's a little surprising. Oh, here, let's reset. '8081 user stream. Okay. I don't really know what to think about this, but I suppose that, you know, this function ideally is going to produce, you know, sort of infinite results. Not actually infinite, but maybe infinite. And then you're just going to send this off to some sort of, I don't know, pipes or conduit like thing to process this? Is that the idea? I don't really know what this is for necessarily. So yeah, anyway, okay. Does anyone know in the chat what streaming endpoints are used for? Like an example? I can't think of a great example, but I could see how you would have, like, you know, you're querying from a database and you have a bunch of users, and then you need to do something with these users, like figure out, I don't know what you would need to figure out, but something. The total cost of, or total sum of someone's bank accounts or something like that. Okay, so it says that we can now write web services using servant. And we got some other stuff in here, but we'll get to that in a second. So one thing I do want to do real quick is error, I think. Let's fix this. Let's see if we can fix it anyway. Stream working. How's it going? I'm doing well. I have the day off today, so I decided to do a little bit of streaming, and yeah, we're learning about servant, just kind of hanging out. How are you? What are you up to? Ah, Let's go fix this error. Maybe we can fix it. Is the docs not in here? Oh, maybe they're fixed and they just haven't been put into place. Tutorial. It looks like they fixed this because if you look at this, there's like fixed small typos 2 months ago. So let's see what's in here. Look at that. There it is. Okay, so they fixed that. They fixed a bunch of these little typos. Okay, cool. So we don't have to do anything, which is nice. It's just apparently not served yet, so it'll be nice when that's available, just because it doesn't look very great. Okay, cool. So let's keep going, I guess. So we did all of this, so I guess the next thing is querying an API. Is that what's going to happen? Yeah. So generating JavaScript functions to query an API. Why would I want JavaScript functions? I'm not sure. So I think that we're going to talk a little bit about being a client to an API, I suppose. And then we'll probably skip over this JavaScript functions because I don't write any JavaScript ever. But I could see how that would be useful for somebody who's actually doing web programming stuff. I don't know what this means, documenting an API. And we'll probably look at the authentication stuff. But my plan was to only stream until like 1 o'clock. So it's been about an hour. We can check uptime. I suppose I should put uptime on a timer, huh? Yeah. So we've been alive for about an hour, but also I think around in an hour, Soding gets on, so I assume everyone will just move over there. I think he gets on at noon. Okay, so while defining handlers that serve an API has a lot to do it, querying with an API is simpler. We do not care about what happens inside the web server. We just need to know how to talk to it and get a response back. That said, we usually have to write the querying functions by hand because the structure of the API isn't a first-class citizen and can't be inspected to generate the client-side functions. Wouldn't it be... Why is this not more of a... Like, why couldn't you just query the API to get back the shape of the API? Is that a thing? Do people do that? I don't know if anyone knows, but that seems like it would be a useful thing if you had, a truly open API that you wanted people to explore. Why not just provide them the schema of the API in a parsable format or JSON or something, such that one can, query it? Does anyone know of cases where that happens? Or why do you think that doesn't happen? I could see that being an issue if you didn't want to show everyone. Like, I mean, you get to define what the GET request ends up looking like, so you can only show them the stuff that they need. I suppose just having documentation is better. I'm not sure. Anyway. Okay, I'm going to move on from that idea. Servant, however, has ways to inspect APIs because APIs are just Haskell types, and GHC Haskell lets us do quite a few things with types. In the same way that we look at an API type to deduce the types the handler should have, we can inspect the structure of the API to derive Haskell functions that take one argument from each occurrence of capture, request body, or query parameter, and friends. We already did the tutorial. By derive, we mean that there's no code generation involved. The functions are defined just by the structure of the API type. The source of this tutorial section is a literate Haskell file, so first we need to have some language extensions in words. So let's okay, let's just create a new project for this one, I guess, and let's get this set up again. I need to make sure that it's okay. Good. It's on your screen. Should be on your screen just fine now. So let's close this project and maybe we'll want to put this into Git at some point. Would people want to see this code in Git? I mean, it's just a tutorial online, so it seems weird that you would want to read this code. I also was not documenting it super careful. Just kind of doing it to do it. I do put a lot of code online, but it doesn't seem like this is the right place for that. Okay, so here's this, and then we're gonna have to start here. So what are we gonna need? We're gonna need servant client, I guess, and servant ASIN, and probably this network HTTP client thing, but I forget what that looks like already, so bear with me. We probably need this. I mean, we'll see, I guess. But I think we do need that base compat thing. And let's put that up there. I suppose that's probably all we need for now. We gotta edit these files real quick. We're not gonna have any type completion because we're gonna need to compile all this stuff. Whoops. Okay. We need our language extensions so that we can build our API type. We're probably gonna need more. But we'll get there. Oh, this. Get rid of this. Can I put these on new? Is this a thing? Okay, and then let's just build this and see how far we get. One thing I like about just doing these sort of tutorial things is I'm feeling a lot more confident about just like getting Haskell projects set up. I mean, in this case, obviously we know what we need, but it definitely is a lot easier to set up from just get the sort of getting used to the motions. Okay, we'll stay here for a second. Are you still here, stream working? I didn't hear from you. I mean, I guess you don't have to respond to me, but this streaming thing's a lot more fun when people talk to you. But I understand why people don't want to talk. They're doing other things. I mean, I watch Twitch and work a lot, so well, working, leaving Twitch on. Ow. Need to get a new chair. So I got a keyboard coming. I'm gonna go buy a new pair of headphones so we can listen to music in stream. Although I sort of get distracted by music, so we need HTTP client 27GO. But I think at some point we're gonna want to have sound, because if we get bits and things, I want to be able to hear those noises. Although I guess I have to watch my own stream to hear those noises, or open up the Twitch API or the Twitch dashboard. I don't actually know how people do that. Okay, so this seems to work now. Really, I don't know how to stream. Okay. So now we need some of these. Should all just work. Yep. And then we're gonna have API type, which is gonna be really hard to read. Let me put this into a slightly better format, because it's kind of hard to read here. This is basic code from, we looked at this code before, but I'll add some annotation here so that it's clear in case anyone doesn't know what's going on. Okay, so this API gives you a get position x, y, and these are captures. So like this, okay? For anyone that's not familiar with APIs, I suppose this is helpful. Why do you gotta do this, kitty? Then we have a get hello name and a post marketing. Guess that's it. Okay. What we are going to get with server client here is 3 functions. One to query each endpoint. Each function makes available as an argument any value that the response may depend on, as evidenced in the API type. How do we get these functions? By calling the function client. It takes 1 argument, a proxy to your API. And here we go. So, kitty, stop biting me. I'm sorry if I'm yelling into the microphone, but like literally biting my feet right now, which is pretty funny, I suppose. Well, this is pretty useful because, you know, clearly this is weird. What's going on here? Complaining about, seems that we're, why am I not getting any type checking? sure. Okay. Oh, new made. French Alps. That sounds cool. What are you doing up there? Vacation, I hope? Conference? Sorry if the connection sucks. Unfortunately, I can't help you there. Visiting friends? That sounds great. Okay. What's going on here? I'm a little confused. So let's build this project, I guess, and see if we have some errors that we just aren't seeing in VS Code or something. Yeah, here we go. Okay. I missed we missed some stuff because, oh, well, it's right there, I suppose. I must have not copied that, I guess. Is it gonna fail now? Doesn't seem like it. I'm not sure what's going on there. So we got client info, but we missed the email type completely, apparently. I thought we just copied and pasted this, but apparently we didn't. A little confused, though. What's going on? Streams look interesting as always. Be sure to check it out later. Yeah, take it easy, new mate. I'm sorry you're not having a great connection, but hopefully I'll see you on the next time. But I will put these on YouTube. I just recently exported like a bunch of them, so I need to clip them and then send them off. I'm a little confused right now. We're not getting any. Anyway, I think the point here is that we're writing a function that's pattern matching on these things based on our API type, and this client function is basically figuring out behind the scenes what's going on, like this. But for some reason, we're not getting any type checking. I don't know why. Anyway, okay. So we'll just keep going because I'm not sure what's going on. So client API returns client functions for our entire API combined with the alternate infix operator for API types. I'm not sure what the right terminology here is. I mean, it's an alternate. It's this alternate right here, which we can pattern match on as above. You could say client calculates the correct type and number of client functions for the API type it is given via a proxy, as well as their implementations. So what if we get rid of one of these? Will it fail? I mean, why is it failing in general? Something is broken, but I don't know what it is. Let's see if this builds. Yeah, it compiles. Maybe we'll get type checking in here now. Nothing. I don't know what's going on. I don't know. Anyway. Okay, if you have an empty API in your API, server client will hand you a value of type empty client in the corresponding slot, where data empty client equals empty client, as a way to indicate that you can't do anything useful with it. Okay. So you either have your API or some empty client. What is this? URI scheme to use? Simple data type to represent the target of HTTP requests for servers. For servants automatically generating clients. Do we use this? Confused. All right, so we need these things, I guess. Don't have. Why does this have an empty deriving clause? What does this do? I've never seen this before. Okay, let's Google that. Haskell empty deriving clause. Um, let's see if there's anything in here that says it. Oh, this is like a wiki. This probably isn't going to be useful. I don't know how to Google this. It's interesting to me that this is completely empty. I'm not sure what that means. Does anyone know what this means? I can ask. I'll probably ask in the other Discord channel. Not mine, but someone else's. Anyway. Okay, so here's our. No. Well, we don't know if anything's working because for some reason hey, enjoy your stream. Enjoy your stream. Thanks for lurking. It's appreciated. We need to keep that viewer count above 3 apparently. I don't know how long that takes. Parse on input. Interesting. All right, so something is going wrong, but we don't know where. Because this was, oh, yeah, we do. I lied. We know what's going on wrong there. It was just tabbed out incorrectly. Yeah, this is confusing. This is broken. You can't have that there. That's broken. Okay, so maybe we don't need these things. Maybe they were just showing us them. But again, you can't tell. It's impossible to know. Okay, that's fine. Anyway, this is clearly broken, but we don't need to type this code in, so it's fine. Okay, so now we have our client functions. So this gets us our client functions, and then we can use them. To build up queries, I guess. Interesting. So cool. Okay. I don't know what to do with this, so I guess I could run like we could put this in some other executable, I guess. How do I do that again? Yeah, so we could create two executables here and then run one of them as the server and one of them as a client, I suppose. But we need to finish the server, so let's do that. So if we had this API, then we have the proxy, so we just need the server, which is serve API, I believe. And then we need the app. No, that's not right. This is, I think it's return API. And then this is application serve. What's the order of operations here? I know I'm doing this wrong. This is what happens when you don't have a lot of practice doing this. Okay, so server is this thing. Serve API proxy server. Okay, and then the server needs to deal with all the people. So you're gonna have position or hello, or we already actually wrote this, marketing apparently. So we could probably just copy and paste this. I think it's the same thing. Yeah. Source API. Just need this. Oop. Well, again, we don't know that anything's working because something broke and I don't know what it is. Okay. Type signature for server API lacks an accompanying binding. What? What does that even mean? Oh. That's what it means. It means I have a typo. Okay. Try that. Okay, we got some issues. We don't have servers, which means I guess we didn't import servant. Wait, why is this streaming stuff in here? Did I just copy and paste that from somewhere else? We don't need any of it. We need this. We need this. But I suppose we can just change this. We probably don't need these. Although maybe we don't need that one. We need 4 each. I think we just need these 2 things. What's up, Soding? This is your favorite Haskell, and we're currently trying to learn about servant. Yeah, it's pretty weird, and something's broken with my VS Code, so I can't actually see any types. So basically, a useless squid at this point, or something. I'm not good at Haskell. It's very hard. Very hard. I lost my train of thought. I guess we just need to build this thing. I suppose we could also run GHCI next to each other. What is this called? Servant server, I think is what it is. Dash server. I think that's what we need. Close this and wait. Ugh. You're streaming at noon, right? I'll raid you with my 7 viewers. Well, it'll be 6 because you'll be gone. I should just switch to the GHCI D style of working on Haskell like you do. I can't get used to Emacs. I know you have a really nice development flow, but I just, I learned Vim too long ago, and I'm just lazy. We're compiling. Okay. Right, that's the wrong name. That's interesting. This is now failing. Okay, we don't have this either. That's fine. That's interesting. So what did I break? Oh, right, because this is supposed to be the API proxy, I think. And then I broke something else. But where was it? Yeah, see, why doesn't this work? I don't understand. What is broken in this file? Compiles fine, but doesn't work. I don't know. Okay, anyway, let's just look. I fixed that, and we don't have a server, apparently. It's called Server API. So we gotta fix that. And the other thing is we need this email for client function, which is there. I already wrote it, so no reason to write it twice, I guess. Okay, and then let's try to build this guy. Okay. Type int with actual type integer. Right, let's see where. Right, I decided that I wanted to use these as integers before, so that's gonna break that. And you know what? Now we definitely want to just do, what is it? GHCID something. Um, we're gonna use GHCID because something's really broken here and I don't know what's going on. I don't know why VS Code is giving me crap today. Unfortunately, I don't have enough screen real estate to, like, do anything. Um, okay, so I think first we should do this. Hang on, to get this sized right. All right. Client, and then we do GHCID, and it's like command or something. Yeah. Stack GHCI, I believe. Okay, cool. So then, gotta go figure this error out. Okay. So could it match string with maybe string? Could I match string with maybe string? This is probably because I did this differently before. Hang on. I think it was the last time we ran cat. Nope. Server source lib. Oh. And we need this function apparently. Okay. Nope, we're not doing that anymore. Do. Okay, next thing. We have integer int issue again. So somewhere in here it says int. Okay. Client info. Okay. Position. Oh my goodness. It's awful. Okay. So that took a while, but that's okay, I suppose. I've gotten so used to using VS Code, it's terrible. I've gotten so lazy. I need to stop doing that, I guess. My Vim skills are going in the toilet because like I had Vim skills before. That's a funny joke. I'm definitely getting a lot worse. I'm not happy about that. Okay, anyway, so now we have this piece. So what we need to do is create basically two executables and one for app, one for the client, I suppose, so that we can run both of them. I don't really care what it's called. So well, so this is going to be like server client oops. Oh, that's going to fail, right? Okay, so we need, this is going to be our main function for the client. So we just need to run. And then for this one, we need the server, which is, I already forget how to do it. And I'm bad. Source guy, not here. Run 8081 stream API. Okay. Well, that's not what it's called. I don't think I have even the nice Vim setup here either, so I don't think I have like, oh, I do. Okay, nice. It's better than nothing, I suppose. I need to do one more thing real quick. Let's move this over so we have some more real estate. We don't really need a lot of space over there. That's a little better, I suppose. I forgot I actually had this installed, so kind of useful. Just app, right? This one's right. Need app. Gonna have to import qualified servant. What is this? Where does this run function come from? Yeah, so we're getting qualified lib.app. Okay. This probably comes from here. Okay. Warp. We need to compile warp. I think it may already be included. Yeah, and then I need to fix my package .yaml file. So we have our first main, which is going to be our server. And then we're going to have our client. I think that's do these both need to be called? I'm confused about that. Because that fails over there. Yeah, this fails here too. What's the correct... Okay, I mean, I guess we can call the server main, I don't know. I don't really care. It doesn't matter what it's called. To me, anyway. Oh, but I gotta fix that. How can they both be main? I don't understand. What is the proper setup here? Do you just have app 1 and app 2 or something? Should I do this? I don't know what I'm doing anymore. It's very confusing to me. Is this the proper way to do this? Or do people make subdirectories inside of app? I have no idea what the structure is supposed to be. So server source dir is server app client x exe entry point main client app, I guess. Does this freaking build? Wonderful. Okay. Got it, I guess. So then the only other thing I need to remember how to do is actually launch these things separate. So there's like stack, I think it's exec server exe. Is that what it's called? Oh, well, I should do the, oh wait, no, that's the right directory. Stack, it's either run or package. What? Do I just write? I don't remember if it's run or what's the other one? Exec or something? Why is this doing nothing? Oops. What is going on? Oh, maybe it's just running and I'm just insane. It is, it's running. Okay. Ay, ay, ay. Oh man. Sorry, I'm just dumb. All right. So anyway, that's what a client ends up looking like. So that's kind of cool. Just like hoist server allows us to change the monad in which request handlers of a web application live in, we also have hoist client for changing the monad in which clients functions live in. Okay. Oh, I'm supposed to read this out loud. Sorry, got distracted. Client M rarely or never is the actual monad we need to use the client functions in. Sometimes we need to run them in I/O, sometimes in a custom monad stack. Host client is a very simple solution to the problem of changing the monad the client runs in. Host client. We need our proxy, the natural transformation, and the client monad itself. The conversion function above, just like the ones given to hoist server, must be able to turn an MA into an N for any choice of type A. See this in action for our example. We first derive our client functions as usual, with all of them returning a result in client M. Look at this formatting. What is this? I have never seen this before. Interesting. I didn't even realize that would compile. We finally decide what we want the handlers to run in I/O instead by post applying run client M to a fixed client environment. Okay. Querying streaming APIs. Over with use a different client. Server client streaming, which can stream but has a different API. In any case, here's where we write a function to query our API. Sorry, I'm sort of losing steam. I don't know why. Okay. So for, look back to this, instead of run client M, the streaming client provides with client M. The underlying HTTP connection is open only until the inner function exits. Inside the block, we can, for example, just print out all elements from a source IO to give some idea of how to work with them. Okay, with client M. C is our source. The environment is whatever client env is, which I already forgot. Client env. Oh, that's just the type that we're trying to. I see. Okay. Interesting. We'll probably be playing more with this later. How do I get this back? Okay, so this is about documentation. It doesn't look very long, so we'll quickly look at it. But I think that we'll probably just switch over to and watch Soding instead, because I'm I don't really want to think about authentication yet. Um, although I do need to think about it. So I don't know when we're going to be able to bring this back up again. We'll see. Okay, documenting. While servant can see, for example, that there are 3 endpoints, we've seen this a bunch of times, so hopefully that's not scary anymore. The response bodies will be in JSON. It doesn't know what influence the captures, parameters, request bodies, and other combinators have on the web service. This is where some manual work is required. For every capture, request body, response body, query parameter, we have to give some explanations about how it influences the response, what values are possible, and the likes. Here's how it looks like for the parameters we have above. Instance, to capture, doc capture x, integer position on the x-axis. To sample? This is weird. Okay. Types that are used as request or response bodies have to instantiate the toSample type class, which lets you specify one or more examples. Here, kitty, come here. Matter. One or more examples of values. Captures and query params has to instantiate the respective toCapture and toParam classes and provide a name and some information about the concrete meaning of that argument, is illustrated in the code above. The empty API combinator needs no special treatment as it generates no documentation. An empty API has no endpoints to document. With all of this, we can derive docs for our API. Interesting. API is a type provided by servant docs that stores all of the information one needs about a web API in order to generate documentation in some format. Out of the box, servant docs only provide a pretty documentation printer that outputs Markdown, but the servant pandoc package can be used to target many useful formats. Servant's Markdown pretty printer is function named Markdown. That lets us see what our API docs look like in Markdown by looking at Markdown API docs. Okay, interesting. I guess this is useful because you don't have to provide less documentation. Come on. Hang on, I gotta deal with Cat, as usual. Come here. Get out of here. Okay. We gotta give him a little love. Here's Kitty. Say hi hello to Andre 3000. After popular. Okay. Is this enough love for a little bit? Anyway, so apparently you can just generate API directly, documentation directly from your API in Servant. Ugh. Everywhere, hair, all the time. So that's pretty cool. And it'll tell you what content types are supported and examples. Is JSON considered valid JavaScript? That's interesting. I would assume that there'd be its own JSON type. I didn't know that before. Okay, cool. That's neat. We can also add one or more introduction sections to the document. We just need to tweak the way we generate API docs. We also convert the content to a lazy byte string, since this is what Way expects for raw endpoints. What does that mean? WAI has documentation on the API itself? Or in the API itself? What are you doing? Or customization can be done with markdown with function, which allows customizing some of the parameters used when generating markdown. The most obvious of these is how to handle when a request or response body has multiple content types. For example, if we make a slight change to the marketing endpoint of our API so that the request body can also be encoded as a form, Oh, and then you have this to form from form, and then it just adds that information there as well. That's interesting. If, however, you don't want the extra example encoding shown, you get to use markdown with def rendering options. Okay. Where are these functions? We've not seen these functions before. Oh, respond right there. So response OBS. I don't know what that means. All right, so they are serving the documentation directly from the API. So I don't remember why we brought that up before, but apparently you can do that. That's cool. I don't really want to talk about this now, and honestly, my butt is starting to hurt from sitting down on this chair. I need to get a new chair. I've talked about that a few times. I think that Soding is about to start streaming, so I'm just gonna. Can we raid? Like, is that a thing that we do? I don't know how we do that. Do I have to do that in Twitch? Can I do that? Like, I don't have any clue how this works. Anyway, I think I'm done for the day, but we do need to get through this authentication stuff because it's going to be important. What's this cookbook? This could be useful as well. I don't know if we'll go through this, but maybe. Yeah. But anyway, we got some other stuff to go through, so that's kind of cool. But unless anyone has any questions, I think I'm done for the day. Short stream today because, like, you know, I am off today, so I'd like to relax a little bit as well. And this is very tiring. So I will catch y'all later. Thanks for watching, and go check out Soding stream, which I think starts now. Not sure what he's working on today, but we can go look. That one. He has a nice schedule. Should be good enough to get here. There, this one. He's writing a game in assembly, which sounds hard. Our goal is to write a game that fits into a 512 bytes bootloader and works in 16-bit real mode on an IBM PC compatible machine without any operating system. All right. That's wild. Go check it out. He's pretty funny. Anyway, I'll see everyone. I'm not here tomorrow. I'll be here on Sunday. Normal time. And we're going to do thinking. We're going to continue our thinking with types learning session. So take it easy.